this one schedule it says so we're gonna do NM paper or we're gonna do like
Which course?
yours.
Show me mine. Yeah, but this is in-person course, right? So we kind of doing the same as the midterm.
Yeah, I think so.
Yeah. Yeah. So you will be here in person and you would just do it. Yeah. Yeah. Yeah.
So just like me.
Just bring the laptop. Yeah. But if you don't have laptop, you just have the paper based. Yeah. 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 Sorry. Oh, you cannot test it. Yeah, because there's no file you can access to. Yeah.
I just wanted to make sure is this correct? Are you supposed to look like this?
Depends on your pointer's location, right? Because at the beginning it's pointing at the first argument, so you might want to actually increase the first, right? Yeah, something like that. Yeah. Yeah. Okay, so this first part should be very straightforward. As long as you know what does the read and write do, right? Read from the 0 file descriptor and then write out to the 1, right? Like this. So again, we have been showing that many for 3 times already. Okay, the next part to create it is this opening the file, right? Now, if we do have argument passed in, we wanted to open them up one by one and do something else, right? Like here, we're only dealing with the opening part of it. All right, so essentially, you just want to get this file descriptor. That's all you need, and then you just open that by going through your argument. I think the tricky part here is that when you open this file, you wanted to make sure you are looking at the right argument. So yeah, because at the beginning, this argument variable is pointing at the first argument, which is the program name, which is you don't want, right? So you increment first, and then you take this file path and you open it up with the p mode, which we defined at the beginning, right? Finally, again, right from this file, which is again very similar to what you have done already, but just simply replacing the file descriptor from 0 and 1 to the new ones you just got. Well, actually, you still output to the 1, right? But the input is different. So nothing too surprise here. So just replace this 0 with the FD. That's it. Any question? By the way, yeah, in this function, we're using this p error, which is from another libraries to avoid creating our own error function, right? So the idea is very similar to what we have looked at earlier. Okay. Move forward. So the next two functions we're going to talk about is seek and Lseek. They're doing the same thing, but let's look at the Lseek first. So imagine you're opening the file, but instead of always reading from the beginning of the file, sometimes you want to maybe reading from the middle point of the file, or it's reading from at the end of the file sometimes, right? Or right, or more often like a write to the end of the file, to append, right? That's more often to happen. So this is how you do. Essentially, you're moving your position, right? Using this Lseek. The first one is file descriptor. Second is the offset, like how many positions you want to move. And the last one is the just like a starting point. Okay, 0 means the beginning. 1 means whatever you are right now, and 2 means to the end of the file. Okay, so here are some example. If we're going to append something to a file, right? This is very commonly used way. So Lseek, file descriptor, last point is 2, right? That's the end of the file. The offset is 0. 0L is just a long 0, which means no offset. Sometime like halfway down the road, after you're reading a couple of things in the file, you want to go back to the beginning of the file. So you can use this command to move to the beginning. So imagine you wanted to read a file from a given position inside this file, right? So you want to read from the position in the POS, which is a long integer, right? And from this file. So we will need to call the seek first, okay, to get kind of your pointer at that position. And then you can read using the read command. You can see here is no variable here. You can explicitly see that it's storing the position where you read this thing. Okay, there's no variable is storing like a pointer thing. You can return from this thing. It's hidden, right? But as long as you have executed this part, you're essentially shifting where reading inside the file by that offset, the POS offset, right? And then you read from it. Yeah. So what does the seek do, right? At the beginning, well, in early days, they have this function called seek. Before we have the Lseek. But the problem is it can allow the seek only using the integer rather than the long integer. So that means you can only move very limited amount of space, like that's 16 bits, right? So if your file is super long, you got stuck. You can only move the first part of the file. So how to handle this problem? So they essentially divide a big file by block. So each block is 512 bytes. So essentially you divide that by the block. Then you have to do two operations. First operation is you use seek to jump to the block, a particular block. Then inside this block, you seek again to find your real location. But there's only one function called seek. So how can they differentiate that? So they use two sets of flag. So this, go back a little bit. This last bit called the original argument, right? Origin argument was only have 0, 1, and 2, right? But in this old version of this seek, it has 3, 4, and 5. So when you're seeing those three flags, that means you're seeking on the block level. If you're seeing them on the level of 0, 1, 2, that's seeking in the byte level. So it depends on this last argument. All right, so that essentially means every seek you have to do that twice. Like every long seek you have to do that twice, assuming it's a big file, right? The first step is, again, you seek it to the right block point. The second seek will bring you to the right byte point, right? So when you're seeking the first time, you select the block, and then you keep this origin argument. Whatever the argument you pass in, you use that argument. That's fine, okay? In your second seek, you will set your original to 1. Okay, this is important because 1 means the current position, right? You have already shifted to your block location. You want to keep that position, right? And then from there, you're using another offset to jump even forward to a more precise location. All right, so this is our second exercise. So using this seek function to create a long seek, okay? So here is a